The stream is live. I need an audio check when I just report. I'm just waiting for a couple of more people to join in, and then we'll start. Those who are joining us on YouTube, this recording will be available to you. And in this session, we will basically be covering the concept of open source and how to get started with Git and GitHub. Okay, fine. Hi, everyone.
Hello.
Is my screen visible?
Yes. Yeah.
Okay, cool. Let's start without further ado. Okay, hi everyone. I am Sudipto, and I was an open source fellow with Major League Hacking back in 2021. In the open source track, I basically was involved with one of the leading organizations called ECMAScript, which actually defines how the open source JavaScript language is implemented by the various browsers that are there. So I worked on the language internals, and under that also I worked with Jordan Harband for one of the projects that he had. So that's about me, and I'm also pursuing a master's in computer science at the Department of Computer Science here in University of Delhi. In this session, what I plan to do is to give you an introduction to open source and the motivation for it. And then when we do understand the motivation behind it, we will get started with some of the tools to actually get into open source that will be using Git and GitHub. These tools you might have heard about very frequently. But yeah, we will go some do some hands-on practice with Git and GitHub to understand that we really do get the point of all of it. Okay, so yeah. So would anyone like to just explain, has anyone ever heard of the term open source? You can just unmute and say.
Yes. Yes.
So how do you define it, like in your own words?
Like it's a platform where everyone can contribute to the basically code part and program part where we all can contribute and update the program and all. It's open for all.
Okay, nice.
Hmm.
Okay, so now let us get to the good part. Let's understand what open source is really about. What Dheeraj just said was partially correct, that yeah, we are allowed to have access to all of that code and contribute and make changes to it, whatever. So let's understand what open source is really about. Open source software is basically any software that you can access, modify, and reuse. This is the definition of open, right? You can access that software from anywhere you want, open for anyone, anywhere. It is inclusive, that you do not have to come from a particular nationality or anything to use these softwares. It is open to access. That is, you have access to the source code behind that software, whatever software you are using. You are allowed to poke into the internals and see how things are implemented. If it is a library, you should know how the library methods are implemented and all of that. You're allowed to modify it. For example, if a driver is not working out for you, let's say, you're allowed to modify it and fix that thing. That because you have access to the code, you can do that. You can afford to do that. And if you want, and if the license allows it, we will get to the licenses. But basically, there's stuff to prevent like intellectual property being stolen from one person to another, right? So for that, there are some licenses in place. So we are also allowed to reuse the code that we get through these open source software. But is it monetarily free or not? Do I have to pay something to get the software? What do you think? Does open source
Usually
mean?
it's free, like I've heard.
Okay. So
Depends on the organization.
correct. So that is where this question comes into picture. How do companies with open source products earn and keep themselves how do they sustain themselves? How do they pay the salaries of the developers, right? Large open source organizations that contribute to open source include like Red Hat, and Kubernetes is also supported by the Cloud Native Foundation. So how do they sustain themselves? The question comes from that. So free as in not monetarily free, free as in freedom. So it does not mean that you do not have to pay to get access to the source code of a particular software. It depends on the developer totally, and honestly, like they do not earn anything out of it for most part. But when the companies do offer some open source software, we usually also have a paid version that they host or they run themselves, they manage themselves, right? So they have a service as a like the platform as a service, or that particular service that they are offering that for a particular amount of subscription or whatever that is. That is how they earn their money. But the base product is open for anyone to access, modify, and reuse, and just publish it anywhere, right? Depends on the licenses, obviously. Again, some licenses say that you have to keep the name of the original developers and all of that. So that is what we are talking about. So Linus Torvalds has this particular quote. He wrote this somewhere, that in real open source, you have the right to control your own destiny. So basically, it's just that you have the code that you want to use or share with the entire world. But what you do with that code, that lies completely in your hands. You can charge a fee for selling your product to a person, right? For example, if you design a software and you sell that for XYZ amount of money, but you also give the entire code along with it, that is also open source, because you're allowing the person to control their own destiny. Like basically they can reuse the code and modify the code whatever they want. So that is the real meaning of open source in this sense. Again, Richard Stallman. So let's get back 1 second. Linus Torvalds. Does anyone recall who was Linus Torvalds, or who is Linus Torvalds?
He created Linux.
Yeah. So he created Linux, the Linux kernel. Linux is not an operating system. Linux is just the base layer in that operating system. He created that by himself as a college assignment. And he also created one of the tools that we are going to learn today, Git. So that's interesting. Richard Stallman, a controversial figure. Well, but yeah, the free software is a matter of liberty. It's not a matter of price. That free as in freedom, free as in free speech, not as in free beer. So it's not a free lunch basically. It's just that you can afford to speak something, you can afford to put something out there, and then you are free. It's not you don't need any money to get out of there. So that's there. Again, one of the things that Richard Stallman talks about is that open source is a software methodology. That how do you view software as a product, or like just a bunch of code, or the developers behind it. But the free software movement is a social movement. It is political. So that comes into the picture. So sometimes these corporates like Intel do give you open source products, like for machine learning. They are coming out with new libraries that are open source, but then they are not really free as in freedom, because they have some proprietary, some logic going behind the scenes, that it is optimized with their processors and all of that. But you are allowed to tweak many things. So that is open source, but that is not free. So there are 4 freedoms of open source when we talk about it, right? So the 4 freedoms, what are they? First is run. You should be able to run the software for any purpose that you like, whatever be the program by itself, but you should be able to run it for any purpose. You should be able to study how the program works from the inside out at your leisure, whatever you want to do with it. If you want to just learn how an algorithm or a particular method is implemented, you're allowed to do that. Otherwise, anyway, you can study however you want. You're also free to redistribute and make copies, and you can help your classmates, you can help your peers and neighbors. This does not actually amount to piracy or anything, because this is one of the freedoms that open source gives you. So there are some manifestos for the free software and open source movement. The open source foundation is also there. The free software movement is also there. They are disjoint. So their manifestos have these particular freedoms like in their constitution. So you're allowed to redistribute things that are open source. Again, depending on the license. If the license says that you cannot redistribute, then you cannot, but then it is not open source software anymore. वो freedom नहीं है then. Then we come across to the freedom of improvement. We have the freedom to improve the software and release all of those improvements that we actually do to the public, so that the whole community benefits. It's just not you and the company that has developed the software which is benefiting from this, right? So is this clear? Does that clear some of your doubts? Someone please reply. Yeah. Okay. So we understood what free software and open source software is. Then why should I contribute to it? What is the motivating factor? Here the title is, why should one contribute to OS? This OS is not operating systems. This is open source. So you basically what is, just let me go back to these slides just for a bit. I'm taking a tangent here. So even if anyone has a trouble understanding, so any software that is accessible to you, which you can see, study, modify a little bit, and given the right licenses, reuse it, that is open source software. It can mostly be accessed without any fee. The open source software is everywhere, like from your PlayStation consoles to your Macs, everywhere the open source software is being used, not only for developers also, because there are some examples. Can someone just give examples of some open source software that we use on a daily basis, but that is not for the developers?
Android phones use Linux, and Linux is open source.
Okay. Well, Android is also open source, by the way. It's not by Google. The Android operating system. The Google services are on top of it. Again, any other example? You must have used VLC Media Player, right?
Yeah, and like not Open Office as well, Apache, but that's not into the mainstream.
Yeah. VLC is mainstream, I guess. Again, why should I contribute to the open source ecosystem? So one of the mentors that I had during my journey, they had said that they met very bright students in this field, right, in computer science, who are very good at what they do. No hate to anyone. Like, they are very good at what they do. They are very efficient at writing algorithms and writing software. but they have never seen a source code of a large project. Do you understand what I'm talking about?
Yes.
Yeah. So they are very good at like what they do, but they have never seen. I'm just talking about that particular set of people who have never seen the source code of a large project and how it is structured and how have others done it. Like the skills of writing large programs and to just appreciate how others have done it is totally disjoint from what it is mutually exclusive from what skills you actually need to write specialized short like small programs. I hope you get the difference. Just I'm hoping that you get the difference from it. So why should one contribute to open source? First of all, when you actually do these changes, like you have the code, right? You can read the code if you want. Obviously, if you want, you get some real world software development experience out of it, because even if you move to a corporate or any startup, you will be given some code base to work on, right? You have to go through that code base. You have to understand it. It gives you some skills in that aspect. There is a need to conform to standards again. These open source projects, very large projects, if I talk about, like say, let's say Kubernetes, Linux, or even Git, because it is also an open source software, right? They have some standards of code. Like they conform to some standards and they have a certain quality that is in the entire code base, that is reflected in the entire code base. So this need to conform to these standards. So if I write some improvement for that software, I need to match that quality, right? This need to actually match this particular quality, this helps you upskill, and this gives you an exposure that you cannot get in many of the smaller companies. Even if you work for years, you get an unparalleled exposure, and you also come across people. You have to talk to many people in open source, because it's not only always a single person driving the entire project. There are sometimes hundreds and thousands of developers who are working on a single project, and you then need to talk to the right person for whatever part you are working on or whatever help you need, right? So soft skills, you need to communicate very effectively. It puts your skills to the test, because like you say that you are good at C++, but then you will understand that you are not when you actually go to a larger project's code base and see some experienced C++ developers implementing the same stuff. There's a difference. Why there's the difference? Because they are conforming to some standards, and you are not you haven't seen it being done that way, right? So you have to be open. You have to be very open-minded when going through these code bases. But that is also one of the motivating factors to contributing to open source, because you learn all of these skills. You have to be learned to how to be patient and flexible. This open source ecosystem gives you, because it's not that you make a software or an improvement to a software and it gets like integrated or appreciated right away, or the developer even notices it right away. It sometimes takes months. So you have to be learned to how to be patient and flexible. Sometimes fixing something, you can sometimes think about giving up on something if you are not able to solve that particular thing. But then it gives you that platform that you can ask the developers when you are actually stuck in something and get out of it. Again, you get satisfaction out of it after the entire struggle of going through understanding all a totally new code base, adding a feature to it, let's say, and then that project or product gets used by hundreds of people around the world. So that gives you some satisfaction. That might mean different things to different people, but I'll show you a very interesting project of mine that's very simple, but it's still used by people today. So that gives me satisfaction. And you also pick up a lot of languages on the way, because you might start with C and C++, but when you actually see C and C++ projects for GSOC, or let's say if you just randomly go to a GitHub repository, you will see that the code there is pretty hard to grasp if you are just coming from simple C++ programming. So you have to be open-minded and be flexible enough to pick up all of these different styles of writing code, different languages. Some particular, let's say, project you are very passionate about, that I know what can be improved in this project, but that uses, let's say, a very obscure programming language that you have never touched. Let's say it's Rust or Ruby or even JavaScript, Python or Java. Like, they might be very unfamiliar with. A person who is just coming from C and C++ development experience, they might be unfamiliar with these languages as well. So you pick a lot of languages on the way, and you have to be flexible enough to switch between them. Contributing to open source gives you that ability to switch between different tech stacks, different languages, and you learn to appreciate after that. After when you learn all of these skills, you learn to appreciate what the work the developers had put in. Then it's all about giving back, because developers created the code, you made improvements, and then that is just giving back to the community. But where can you really contribute, right? You are just a beginner, let's say. Where do you contribute? But before we even come to the question of where do you contribute, right, you have to use the product. You have to use the project before you can contribute. So you have to download that particular project, go through some of the files, see how do I start this project, right? How do I get the development environment going? How do I install this particular project? What are the different requirements? What are the different libraries I need to install, right? So all of that will come when you use the project before you actually jump into contributions. So using the project and getting it set up is one of the major things. It might take you months to get a project set up. If you are working on a very specialized software that needs some let's say libraries that are not available on Windows and only available on Linux and all of that. And even if it's available on Linux, you might have trouble installing some of these libraries, right? So it sometimes takes months to set up a single project. And then you have to learn to ask how to ask. Okay, so if you go to someone and say that hey, can you help me, that doesn't give me a lot to work with, right? That doesn't give me any context of how do I help you. Like, even if someone is the main developer, the lead developer somewhere, if you just come up with that person that okay, I am working on this, can you help me? If only this much is communicated to that person, you might not get a reply. Why? Because it's not a question that is giving me a lot to work with, basically. You have to learn how to ask. Identify the person, or just use a public channel to ask your doubts. Okay? Then just say that, what have you tried? What are you working on? What didn't work out? What are the errors that you are getting? What do you think that could be one of the solutions, or what could be the solutions? Because you should actually make it clear to the person that you have actually tried to solve these issues, and then you are coming up to them to ask about a particular doubt. That is a good way to ask a doubt. So you have to learn to ask how to ask. Open source gives you that way, like, you can learn to ask. Why? Because here people are not judging you on the basis of anything, not on the basis of your profile. They are not seeing your GitHub profile. Sometimes, most of the times, they are not seeing your profile. They're not seeing what you are capable of. They're just seeing the work that you are putting in. That's it. And on the basis of that, they have to help you. So it's just that no one is judging you here. So there are two things. There are two approaches to find projects where you can find the open source projects where you can contribute. Like, either you can go top down, that is, you find one particular project. Let's say you are working on Kubernetes, which is a really popular container management, container orchestration tool, right? This is a very big project. Now you have to learn the skills to actually appreciate what is going on under the hood. So this is one way, that you find the project you care about, then you mentally prepare yourself that you don't know anything about it, and then be comfortable that okay, we can get started by reading these files. Usually there's a contributing a file in most of these projects that is called contributing.md, which actually lists that how, when you are like going to contribute to a project, what are the things that you should know, what are the topics you should know, what are the different pieces of software, or like what part of the software does what. Sometimes these things are given and documented, so then it makes your task easier. Otherwise you have to just breathe and go through it. You have to identify the project structure, that what are the different folders, what are the different files, what do they do. You have to figure that out. But yeah, don't try to understand everything at once. You should start very small and then work your way up. There should not be any like don't let anyone mess with your mess with you, like it's very difficult, you are just doing it for something else, your motivation is different, like you cannot do it, you should work on your other projects, or just carry on with your work, your daily work, whatever you are working on. By doing that, you will lose track of whatever you have done before. So you don't have to understand everything and get overwhelmed. You have to start small and just documenting every day what have you done. One of the good ways to do it is actually tweeting about it. Sounds cliche, but yeah, Twitter or X nowadays is actually a good way, and it's one of the most engaging platforms for open source developers, because a lot of the communication happens on Twitter only. It's not emails or GitHub conversations anymore. It is happening on Twitter. So yeah, just keep that motivation with you if you are going with the top-down approach, because things will lead down. It is infinitely deep, because to know one thing you have to know a lot of other things, and then you have to dive down. The other way is having a bottom-up approach. The bottom-up approach will just mean that you learn these skills, you learn JavaScript, you learn HTML, CSS, the web dev stuff, and then you learn scripting, bash scripting in Python, all of that. Then you are comfortable, you think you are comfortable with it, and then you can say, okay, let me start building my projects and just see that what are the different things that I can contribute to, like finding projects that align with your skill set. Yeah, not your skill level, your skill set, basically. If the project is basically talking about your web development and you are good at building APIs or doing the front end, so that is your skill set. It's not the skill level that you know this, you are a pro at it, or an intermediate at it, or you are a beginner at it. It's not about that. You sometimes find projects that align with your skill set that you're trying to learn, and then work your way up. That is learning more on the go. One particular resource that I would actually like to highlight is this. MIT has this open course called Missing Semester. This you should try out if you are new to this. It gives you some appreciation of how to use various different tools like Git. Again, that is also covered there. That this will not be taught at like curriculum, in the curriculum. This is something you have to figure out on your own. And these things are actually learned while on the job, but you can fast forward things. And what to contribute. So it's not about code, as Dheeraj mentioned in the beginning. It's never about the code. Okay. It's usually not about the code, it's more about the entirety about it. Okay. So sometimes you can contribute bug fixes, features, and all of that. But that is a technical contribution, a code contribution. You can add it to your resume if it is of a good quality as well, right? I'll give it to you. But most of the contributions that happen in the ecosystem of open source, they are non-code contributions, like writing the documentation and tutorials, like designing the logos for the project, or designing the website for a particular project, right? Is it accessible or not? Or creating content for that particular project. Let's say you are going to learn about machine learning, and let's say you're learning about a library called PyTorch, and let's say the documentation website has everything listed for something that was released 10 years ago. It's not of any use, right? it's just about that keeping the documentation up to date also has some effort going on, and this is usually done by the open source people, that because the lead developers, the main developers behind the project may not have the entirety of the time to document things. So you as an open source developer can just jump in and say, ask that, can you help in this particular project by writing the documentation? If they agree, go ahead and do that. So these are some of the ways you can contribute. Then comes how to contribute. So for that, you have to find projects, right? For that, you have to find projects, and I do have a list of resources for that, and I'll show you. First of all is Google Summer of Code. I'm not talking about the enrolling yourself to the program. It's basically an open source program where you get matched with some open source projects, and these open source projects, they assign you to a mentor, and you contribute some code contribution, just implement a feature within a specific timeline, and it's paid also. That is the program, Google Summer of Code. But Google Summer of Code is also a good way to find out projects which are related to your skill set. Then again, there is the Linux Foundation mentorship. You can also use their search tools. I'm just mentioning these programs because they have a list of projects that they have going, like open source software projects, and then you can filter these based on the skill levels and technologies that they use. That is why I'm mentioning them. So Cloud Native Computing Foundation, the developer, Kubernetes is a CNCF particular project. So how do you contribute? You find out a project from one of these particular resources that are available to you, or you go online or go on GitHub and actually search everything through. You join the mailing lists sometimes. That is very useful. You subscribe to their newsletters to actually get through the marketing stuff. What is the product about? What is its main goal? So you then appreciate the project better. And you can join these tech communities on Discord, Slack, or IRC. IRC is Internet Relay Chat. IRC was famous before Discord and any other chat platform was cool, and it still stands strong till today. So IRC, you can join all of these platforms where you can interact with other developers or other contributors who have previously contributed. Sometimes the lead developer might not have the time, but then you have the other developers who have already contributed. So that is there. Again, you have to then scan the repository for the issues. The repository just means the project in this context. You have to scan the project, that are there any issues that are already there that the developers have made it clear? Do they have an issue board or something like that, bulletin board where the current issues are listed? And then you need to get familiar with the project lingo. That is, what are the terms? Projects might use very heavy terms, tech jargon like interfaces, adapters, integrations, and whatnot, and like providers, context. I'm talking about React here. So all of these terms might be very new to you, but you have to go through it and learn about what are they talking about if you want to actually contribute to that level. If you do not want to contribute majorly, you can skip all of that, but your mileage may vary. And usually coding is not the only way to get in. It was not the way for me to get in. I didn't start with code. Start small, contribute code when you are actually very comfortable working with code. Then get yourself a starting point. If you are not sure where to start, just ask, please, and start digging, and then get in touch with the project developers when you do not understand whatever you look into. And you have to try yourself first. Don't go to the developer and say that give me the resources where I can get started on. Usually it is listed somewhere or the other in the project documentation itself. One of the major thing is, do not DM or stalk people on other platforms. There's a code of conduct everyone in the open source community follows. Do not DM people because they have their own lives, and they might even live in a different time zone. So that is there. Do not DM them because they do not have time to look into like personal messages all the time. It's better to ask it on a public forum. Like if it is their GitHub, it's their GitHub, or if it is a email list, you can write an email and get added to the bulletin board or whatever. Do not DM or stalk people that, okay, I have made some code improvement 30 minutes ago. Can you please check? No, this is not the way. Sometimes it might take 2 to 3 weeks to even get a reply, and that is very normal in the open source world. And all feedback is positive feedback, because see, you are not working for any money, and you are just doing things for your own betterment and also for the project itself, right? That is why you're contributing. So anything that is there, even if there are bugs, if you have not done anything correctly, if you have done everything wrong, even then all feedback is positive feedback. This should be like kind of your motto. You have to embrace the code of conduct and do not be a bystander. So if you have some if you see someone who is actually abusing or harassing anyone else in the community, do not be a bystander. So all of these are contribution things. It is, we do not realize it, but behind the scenes it's just that. And you have to open the doors for others as well. It's just that if you are getting into open source, you have to hold the other people also who also want to get into the open source and like help them get into it. And you should not shame anyone. Any form of shaming is not appreciated, and it will be dealt with very fiercely in the open source world. And you have to be very humble, and humility is again one of the core concepts here. So that is there. All feedback is positive feedback. So there are these programs like MLH Fellowship and Hacktoberfest, which actually give you some starting point, as in how to find the projects, how to find some code that I have not written, right? And then I want to understand it. This is the core motivation for open source. So to get started, you can just do one particular thing, that you can ask your friend if they are willing to share their code with you. You have not written that code, right? And can you understand it and try to figure out what it's doing? This is what open source is, and this is what open source means. If Linux was a college assignment, BSD was also a university project, workplace system distribution, the BSD Unix on which the other systems like Mac and PlayStation and all are built on. So that is there. You have to appreciate all of this. Okay, all right. Much about presentations. Let's see some particular things. Okay, so there is this particular website called opensource.guide, where you can get access to all of these code of conducts and how do you maintain balance between different, if you are working on different projects and all, you can go through it in your own time. But what I really want to like show you is this particular, this is the Google Summer of Code website. Okay. If you go to this particular sidebar, you can go to get started and see that there are some organizations. So if you go to these organizations, these will list the organizations which are participating in Google Summer of Code. That means that their projects are open source and they are inviting people to work on their projects. So there are a ton of projects that you can find here. Let's say Wikipedia and all of that, the platform that powers it. CERN, that is their OpenSUSE operating system. Chromium, you can see. PostgreSQL, the HoneyNet project, all of them are there. Some programming languages are also open source that we know about. So Julia is one. Python is there. You can also contribute to Python. GNU, Octave, the MATLAB alternative, TensorFlow, GCC. All of these are like open source projects, and this Google Summer of Code was actually designed for college students to get started and working on real code before they get into the industry. So it is just that when you click on a particular project, let's say Git, this is something we will work with, but it is a project as well, right? So there are some ideas. So the developers who are inviting people to work on their particular problems, they have given a list of ideas. That is what they want. There is a lot of tech jargon here. Again, as I said, that the sparse index integrations, things like that won't make sense to you. unify the filter formats. These are the project ideas that you can take up and follow it through. It's just like a college project in some senses, but yeah. So all of these will not make sense to you if you are not familiar with the code base. So usually what people do for GSOC is that months before they actually register for this program, that I want to do a externship or internship with Google Summer of Code. It's not an externship internship, but it's just a program that you are enrolled into. So months before that, they do their research, that how they talk to the developers to understand what the project is about, how the code is organized and all that. So these were some of the projects that you can contribute to. A more open list, you can actually go to this Up for Grabs particular website. You can see there are many projects which are not that big, right? For example, Medium Play. Listen to audio versions of Medium. It uses JavaScript and Firefox and Chromium to maybe do something. So these are some of the beginner projects which are not that big, because just 13 folks are there. 13 people have tried working on it. This might be a good place for you to start with, instead of actually going into a larger project where there are thousands of people working on it. So you have to like weigh your options. So one of the projects that is very like simple. So this quadratic equation solver, so I had created it 4 years ago, as you can see, but it's just a simple code that actually prints out. You are given the particular coefficients of the terms in the equation, some quadratic equation you can think of, and it just gives you the roots of it. But if you see, 28 people actually downloaded it even in 2023. So there must be some big project that is going on which is actually using this code somewhere. I'm not sure where, but 28 people are actually working on using my code. So, but this was done 4 years ago, right? And this is just an outdated library. I do not even update it or do anything with it, because I was just playing around with it. But it's still used to this date. And I know when I actually had released it, it had like thousands, 19,000, 20,000 downloads in the first week. It's just that. So if you don't find any particular project that you can contribute to, start your own project, however silly it might seem. Okay, now let's get back, because we are running out of time. So then let's see. We are clear with what open source is, right? At this point, just give me a heads up. Do you understand what open source is now?
Yeah.
Okay. Now let's talk about Git and GitHub. These are tools, and you don't need to learn them to contribute to open source projects, as I said. These are tools which you need to understand if you actually want to do a code contribution, as in you want to improve it or appreciate it from its source code, or you need to get access to the source code. Git is to GitHub as email is to Gmail. It means email is a service, and Gmail, Outlook, and like Rediff Mail, Yahoo Mail, these give you access to this service, right? You access these the email service using these particular products, right? So Git is to GitHub as email is to Gmail. Git is actually the tool that you work with, and GitHub is the product that allows you to deal with stuff that you create using Git. That means the software or the service that you are using it is the Git service, but the product that it is allowing you to use that service is GitHub. There are other alternatives as well, Bitbucket, GitLab, some of these are open source as well. GitHub is not open source, even though Git is. Okay? GitHub is not open source. That's irony. But that's how it is, that they did not give you the license to look into their code. But GitLab, on another instance, it is just like GitHub. You can search projects there, you can host your code there. but that is open source, so you can actually get your hands dirty on GitLab. Bitbucket, Gitty, these are different products which allow you to use Git. So now let's understand what Git is and where GitHub comes into the picture. So I do have 15 minutes. Is everyone fine if I extend by 10 minutes?
Yeah, works.
Yes.
Okay. So Git is a version control system. Like jargon. Doesn't mean anything to us, right? A version control system is just a fancy way of saying that whatever I do in the project, I have to maintain the versions of whatever I do at different points in time, and I have to manage all of that. It is just a software or a tool for doing that, nothing else. It is not meant for sharing anything. It's not meant for doing anything else. What are version control systems? You can refer, it is I'll not take much time here, but you can refer to other resources for that. It just is a way of like sharing your code or storing your code, basically. Storing your source code somewhere for your company, if that is. You store your code somewhere, and then your developers, the engineers on your company access it, right? It might be on one particular machine, and then other people are just connecting to it. Then it becomes a centralized system. Otherwise, everyone can maintain a copy of the entire code and then work on their copies and then talk to each other at certain points in time to just sync up that, okay, everyone has the same copy of the code or not. These are the two different approaches. Git is one of the latter approaches. It's one of that. It's a very loose analogy and I'm oversimplifying a lot of things. But you can find other resources which talk about this in a much better way. So it is a version control system for maintaining your source code. The source code management, it is a part of software engineering pipelines. What it does, it maintains a special folder called .git, which is hidden. Anything that starts with a dot in Linux is usually considered hidden. So it uses this special folder to maintain the state of your project directory. Project directory just means the folder where your code is stored, right? And you use Git to maintain the state of that directory over time. It's just that. And for doing that, it uses a special data structure which resembles a directed acyclic graph. You don't have to understand what that is. It just means it is a there is no cycles in that graph and all of that. I will not go into that. Let's skip that. But yeah, it uses a special folder called .git to store your state. GitHub, on the other hand, it is a product that allows you to organize your source code using Git as your way of managing versions. And it also gives you other features like collaboration with other developers and sharing improvements and all of that, making it a social network in some senses. But GitHub is a product that does all of that. But it uses Git to store the projects on its own server. So let's go ahead and learn this from a practical point of view. Okay. So for this particular demo, I had created a virtual machine on AWS. And I'll connect to it in just a minute. Yeah. Is my terminal visible to everyone?
Yes.
Yes.
Okay. Obviously, you need to be familiar with the terminal to do this, but let me simplify things. So what I'm doing right now is I am going to the downloads folder, right? I'm now in the downloads folder, and I'll now connect to this virtual machine. You don't have to understand what is going on here. So basically, I now have a particular machine that I'm connected to, which is running Ubuntu, which is one of the operating systems that uses Linux as its kernel. So there's that. You can also do this on Windows if you want, but Git by default, it's native to Linux, and developers usually prefer a Unix-like system like a Mac or a Linux system to work with, because all of these things are already installed, already available to you. These tools are already available to you, terminals and all of that. Windows also has a terminal these days, but I don't follow that much. Yeah, so to actually use Git, you just have to write this command, right? Git. What it does is that it gives you some information on how to use the Git, because there's some usage information, because this is a command line tool. This is the Git CLI. How do you install it? In this case, it came pre-installed. This is one of the reasons, like one of the many reasons to use Linux. But yeah, how do you install it? You go to, I guess it's Git SCM. Yes, it's Git SCM. So using this website, you go to the downloads and download a particular whatever your operating system is. You download Git for it and install it. If you do it on Windows, you actually get a Git bash. Bash is usually this terminal. This is called let's see. Yeah, it's using xterm, but like this terminal right here, it is called bash. Like if I execute bash, it's just another program that is running this terminal, right? So you get access to Git bash, a similar command line interface to this when you install it on Windows. There are two ways to use Git. One is using a GUI client, that's a graphical interface. Otherwise, you can use like the command line tool. I'll advise you to stay away. Yeah, stay away from the graphical interface, because you won't understand what is going on under the hood. Once you understand what you are doing, you can then upgrade to the graphical interface. Then it becomes very easier for you to do that. So let's see. Git. Okay, first of all, let's create a project directory. Using ls, what I am doing is I'm just seeing what are the different files and folders that are there in this folder. Okay, let me improvise. Can I do this? Can I do this? 1 second. I'm just opening VS Code. Nothing fancy. I'm just trying to connect to this particular machine using my particular using this command, whatever that there is. But I'm also opening this machine on VS Code. Okay, 1 second. Connect to host. What is the host name? This is the host name. Just doing these things on the fly. Okay, what it is saying, I have to connect to this remote host. Acha, user at host. Yes. Permission denied. Open SSH configuration file. It's just better if I use this, right? This entire thing. But using VS Code also, you can get access to. You can access other machines using VS Code. Anyway, let me search. Let me just figure it out. How to do it quickly. One thing. 1 second. Using particularly Yes, okay. Add a new SSH host. Yeah, this is how it's done. I can update this. Host added. Let's connect. It's now setting up VS Code in that machine. Okay, now we are connected and ready to go. Let's see. We were in this folder, right? Where were we? So I was in this folder, /home/Ubuntu. I have opened this particular folder here again. So what I'll do is I'll create a new folder called project. Okay. And I'll open VS Code in that folder. How do I do that? CD project. Can everyone see the terminal on the VS Code that I have?
Yes.
Okay. So I've moved to the project folder and just opened like this particular VS Code in that particular folder only. It contains no files. It is expected that we don't have any files, right? It's empty. I have to first tell Git that I want to use this particular directory for my project, and please track my changes, do the version management stuff that you do. So for that we have the command git init. It just says, it gives me a particular warnings also that the particular names and all are not set up correctly, whatever. We will come out to all of that. But it says that it initialized a empty git repository in this folder, right? But where is this folder? I'm not able to see this folder, right? It is a hidden folder that you will not be able to access. Let's open this folder inside VS Code. Okay. Let me open this folder in VS Code. This is another window of VS Code that I have. You can see these different folders, right? And there are some files again. You don't have to understand all of these files and whatever they are doing. But what I mentioned in the presentation, that it uses this particular .git folder to maintain all the state. It maintains all the data structures that is needed to track the state changes that are happening over time. Right now, your project doesn't have any file. But the moment I add one file, let's say test.txt, if I can write correctly, and write hello world in it, something should happen to it, right? How do I see that there has been some change? First of all, let me remove this file totally. I'll create it again. There is this command called git status that allows you to see what is Git seeing at this moment. What is Git observing? First of all, it is saying that there are no commits yet, nothing to commit. At this point, it just basically means that there is nothing in this folder I had not seen before. It was empty before again, and it is empty now. So I have no changes. I had stored the initial state of this folder. That was an empty folder, but there has been no state change. But if the moment I create this file and I run this command again, it is saying that there is a file called test.txt that is untracked. Untracked means in the history of this project folder, Git had never seen this file before. It's just that. At this point, if you share this Git repository with anyone, your friends or any other developer, they will not be able to see this file. They will not have access to this file because this file will not be copied to them. Okay. So this is untracked file. So how do I register this file with Git so that it can actually... Now there is a state change already that has happened. Git has recognized that it is not the exact same state it was before. It is not an empty repository anymore. it has a file in it called test.txt. In order to actually make this state change formal, we use this command called add, and as an argument to this add command, it takes the path of the files that are untracked or the files that have changed. In this case, I'll write test.txt because this file has changed, right? If I do that, it has formalized the state change. That means the directory was empty before, but now I am not going to make it empty anymore. After this point, it will have something in it. We will just verify. Changes to be committed, this file. It is not formal yet. The state change has not happened yet. It will be happening when I commit it. Commit it means actually doing the state change from an empty repository to a repository with this file called test.txt. Okay, git status is telling me that this file is there. That is ready to be committed. That means the state is ready to be changed. I'll do commit. But with this git commit, you can do it, you can execute it right away, and you will enter a text-based, a terminal-based text editor. Here it is Nano. This is a text editor only, but it is running inside a terminal, so it is not user-friendly all of the times if you are not comfortable with the terminal. So usually you can add another command line argument, -m or -m, and you have to specify a string that describes what you have done. In this case, I can just write this, right? I have added test.txt to this folder. If I do it, there are some messages, but I am just interested in these last two, right? In this case, it is saying that committer was Ubuntu. Why was the committer Ubuntu? Why was it not Sudipto? Right? It is because the user information is not set. It does not know that Sudipto is doing all of this. So let's do it everything from scratch. I will remove this folder because I want to get the credit right. I want to have all the credits for that. I have removed the .git folder. Now if I do git status, it will say fatal, not a git repository. I have deleted the special repository where it was storing all of the state changes. It's not a git repository anymore. Okay. So GitHub has this very nifty documentation about all of it. You can set your name. How do you set your name? You do this git config command is there, and you do something similar to this to set your names, right? You don't have to understand anything here. It's just that you're given this command, and as a layman, you have to execute it because this is one of the things that you will be starting with. You don't know anything about these things, but you learn on the go. What it is doing, it is editing the configuration of the git program, the git command line tool, and it is saying that whenever I do something, please use the Sudipto Ghosh name with it. Do not use Ubuntu name with it. A similar setting is email. So use this this particular email that I have when you need emails. I'll do git init again. Again, I have a untracked file. I added test.txt. I git commit. Right. I do git status. On branch master, nothing to commit, working tree clean. What has happened? It has now reached a state where there is nothing has happened to it after this state. Earlier it was an empty directory, now it is a directory with test.txt file in it. So the state has changed. That I can see with git log that this commit was made somewhere. This commit, I'll get to the commit later. But the state has changed and nothing has happened after that. If I add another file, test2.txt, it will then start complaining that you have actually added another file. Now it is not clean. It is now dirty. This terminologies are being used. Dirty and clean. Test.2.txt, if I delete this file, again it becomes clean. Right. Working tree is clean. Let's get to this. Git log commit. There's a long string here, but the author is Sudipto, and the message was this. This was the date of when I actually committed this. A commit means you have done a state change at this date and time by this person. So when you are working on a large project, if someone changes a part of the code, you are actually able to get to the person who made the change, for whom the feature was like, due to the actions of which person the features actually started working or stopped working. It is called git blame, right? Git blame is usually done with the files that are there. So git blame test.txt. So Sudipta Ghosh had done this change on 15th October, that he had added this line hello world. So it just shows you what was done here. So there's that. Git blame is there, but then let's get to git log again. If you go to any GitHub repository, right? Let's open GitHub. Okay. Let's go to some particular repository that is a bit large, right? Let's go to this nodejs.org. Okay, it might be a large repository, right? It's a considerably large repository. If you click on this commits, this is the UI. Okay, this is the GitHub website. If you click on commits here, you can see that somewhere this particular sequence is coming, like if you can click on this. Basically, when you click on this, this says commit again. We also have a commit, right? It shows an alphanumeric sequence, right? This was its parent, but the commit is this, right? BF13056. BF13056 is actually this. Let me copy it over. This is what they are talking about. This is the starting few digits of that commit string, a commit hash it is called technically. So this is to uniquely identify the state changes that are happening. We also have a commit hash, and it has used the first few substring, a substring out of that of some length as an identifier for that, right? So these are the commit hashes. These allow us to uniquely identify state changes that are happening in a project. What have they done? So who had done this? Whatever is this person name. So Overflowed and Rajagul had added these 4-5 lines to this file that is called collaborator guide.md. They had deleted these 2 lines and added these 2 lines, basically changed something somewhere here. Yeah, so they had changed something here. It is very similar to what we did here, like git with git blame, that what was changed and what part of the code was changed. We know that now. Okay, let us make a change to this file, right? This particular string I have added, I save it now. Can I run git status again? Now it says it's modified. When it's modified, it is not the exact state it was in previously. I have to register it again, formalize it. Git add test.txt. Sometimes this file names might be too long or in a very in a deep directory somewhere. So sometimes there is a shortcut for it. Git add space dot. It adds all the files that are currently there in this particular folder. So now if I do git status again, it will say that all of these files which are there in the directory, which were dirty, are now ready to be committed. I do this git commit, but now I use this that changed test.txt. Right. I do git log again, I can see that there are 2 commits now. let's see what's happening behind the scenes. Okay, so there's this website, nice website called learngitbranching.js.org. What they have done is there was a commit C0. Someone made a change and formalized it and created a commit that is now called C1. Okay, my head pointer is pointing to that. It has another name called main. And this main at C1 has a back pointer to C0. That means my project directory, the folder in its current state, it has a pointer to go back to the earlier state. I think this is pretty technical. Is everyone fine with this particular terms that I am using? Just give me a heads up. Can anyone just unmute and say? Is everyone comfortable with these terms?
Yeah.
Okay. So C1, the commit at this particular point in time, has a back pointer to C0, which was the initial state. Let me sorry, I refreshed the wrong window. 1 second. So what has happened here is my current pointer is at C1, which is the current state. It is called main. This is the name of the pointer. Here what we have is a master pointer. Our head is at master. If I want to change it to, if I want to rename it, I can just do git branch -m main and then do git log again. You can say it is main, right? I have just renamed it so that you can understand it. So main pointer is right now here. If I do git commit, this is just a simulator, nothing else. So what will happen actually is another state will get added and a back pointer to the previous state and your pointer moves forward. It's fine, I can make another commit. This is a linear thing, right? I can do one thing now. I can go back to some point in time. Git revert. Revert to what? Which point in time? I should revert C1. If I do a revert from C1, I get to a state that has the changes of C1 and like the changes which were done in C1 have been undone and the new state is C1 dash. If I do a git commit again, I will carry on with this, right? Now I reach C4. I can jump my pointer also. To do that, I can use checkout. I want to check out what the code was like at C1. So I do git C1, my head goes there, right? From this head, maybe I want to just work on something that I messed up somewhere down the line. I want to start from C1 again. What I'll do at this point is do git checkout -b temp, let's say. So I have another pointer to the C1, right? I can do a git commit again. What happened here? We diverged. Now the commit at C5, the state of the project at C5 is different from what it would have been if we had gone the other route. That through C2, C3, then C1 prime again, then to C4. C5 is not the same as that, but I can jump. I figured out what was wrong in C5. I identified what was wrong. Now it's time to fix it. Let's go back to C4. Or let's go back to main. It's the same thing. You see, when I do checkout C4, it just adds a, what do we call it? A label, another pointer to it. Get checkout C4. it adds a head pointer to it. But when I do git checkout with the name of the pointer, it just makes that current pointer the actual current one. What I can do is I can merge these two branches of the tree, if you can visualize it that way, together. That means I applied the changes in C5. Whatever was wrong in C5, I applied the changes in C5. Whatever the problems were there in C1, I have fixed that in C5. Now I want to fix it here also. So I have done this. What was done, now it has a back pointer to both of the C4 and C5 states. I can continue working on my code and doing git commit. Right. So this happened. What can we call this route from C1 to C5 to C4? This is called a branch. This is called a branch. I can also create now git branch command can also be used to have create another pointer, like temp2 pointer I can create. Where am I right now? I am at main at C8 state. If I do git branch temp2, it created another pointer with the name temp2, but the current pointer is still called main. If I do checkout temp2, then the star shifts to temp2 instead of main, right? If I do git checkout temp, the star goes back to this place. It just means where are you currently. Sometimes a particular state may have multiple pointers to it. It's fine. So let's go back to main. Let's do this in our code. Okay. So here there are no C0, C1, C2, C3, C4, C5. We have these commit IDs. Git checkout. Okay. Now you can see the file has gone back to the state it was. Right. Now I will make some change to it. I will write hi. I'll do git status. Head has been detached, so we have diverged. Okay. If I maximize this, you can see where my head is right now. Master is nowhere or main is nowhere to be seen. I call this as temp. Right. This is my current head. Head is at temp. Okay. I can show graph. This is temp. I can go back to main. I can show git log there. Here something else was there, right? If I see the graph here is different. The graph there was different. There are two different timelines that are going. I can merge these two together. There's a merge conflict now. Why did that happen? Why? Because at this particular line number 4 or line number 3, at one file I had this and the other file I had those. If I want to keep both changes, VS Code extension gives us this flexibility. So I have both of these changes, right? Git status, both modified on both of both modified. It means that we have accepted from both of them. Git adds dot git commit merge temp into main. Git log. Git log graph. You can see what has happened. This is what we wanted, right? From this point, we created a branch, went on a detour, went on a tangent, and then came back to main. This is what has done. This is exactly what I showed you right here. This is the power of Git. This is not GitHub. This is Git. Git is tracking these changes and doing this to you. Doing this to your project directory, more correctly it would be. So this was Git. Let's get to GitHub now. We know how to work with Git. GitHub is a product that allows us to host and share these repositories, right? I'll create a new repository. Okay. Here you have to give the name to the repository, which can be different from the project name that you gave. What was my project name? It was project. I will call it git demo DUCSRC. Keeping it public or private is up to you. Okay. Not done anything else, just created the repository. It says something to me. Okay. It asks me, because I have an existing repository, that's why I'm looking here. It asks me to add an origin. Let's look at that folder. You see, some things have added, some things have changed since the last time we visited .git. Let's see the config. It doesn't have a reference to what folder or what GitHub repository that there is. But the moment we do this, the moment we run this code, that git remote add origin, you see the config now, not the commit edit message. You see the config now. Something has changed. Now it knows by origin you mean this repository on GitHub, and that is what we are working with. The next thing that it says, git branch main. We had run this code earlier. This command just renames the branch because master is not a right way to say, because it is associated with something derogatory. So they decided to call it main instead. Git branch main. This is for renaming. They're pushing this main. What was main? Main is a pointer. They're pushing this pointer to this origin, that is my GitHub server. It is uploading to that, but it is under my account, so it is asking me for my details, right? I'll just copy and paste my password, and it has done some things. It has uploaded these objects to the GitHub remote storage server, whatever that there is. Branch main is set to track remote branch main from origin. So there are two repositories now. There are two Git repositories. At one place where is my machine, I am using Git to maintain my state, but GitHub is also using the Git tool to maintain the same graph on its own server. If I refresh this, I'll see test.txt is there. Right, this is what we wanted. Now GitHub also allows us to edit some files or add some files from the UI also. This is one of the just an additional feature that is given. Create new file. Test2.txt. I can do it this way also. Hello. Commit my changes. It is doing everything that we did on the command line, but in the backend. It's happening, but it's not apparent to us. Okay. Now test.txt, test2.txt is there, but it is not here. How do I do this? How do I synchronize? For this, there is a git pull command, which will actually pull everything, the graph changes, the state changes that are happened on the remote. And now you also have a test.txt here. It's fine. The other features that you have, you can make a copy of this repository, bookmark this repository or like it. You can also like raise some issues that, let's say, let me create a new issue. Test2.txt has a typo. This is a way of communication to the project maintainer that some issue is there with your code. I will see this. Let's see what was the typo. There was no typo, but let's make it 0. Right. But I realize if I do this and if it doesn't work out, if this is a typo and the earlier thing was not a typo, then I have lost my changes, right? Actually, I can go back, but still. What I'll do here is I'll create a new branch. Right. I'll create a new branch. I have switched to that branch. which branch you are currently using. You can just see that what is the current branch you are using. I am on new branch. I do this change, hello, with a 0. I add this, I commit this, fixed what? Fixed issue number 1, git push. Now it says new branch is a new branch on our graph, but that does not exist on GitHub. So git push, this is a short form for that. In origin, we need to create this new branch. Again, it is asking me for my credentials because it is not storing these. There are alternative ways to how to connect to GitHub from the command line using SSH keys, but I'll not cover it here. Now it has done this. What has been done? It has created another branch that we can navigate from here, and here test.2.txt has it fixed. Fixed issue number 1, it says that you can see that it has highlighted it already. If I can click on this, I go to this, and you can see it has mentioned that Sudipto has added a commit that fixes this issue. Let's go to that commit, and you can see the change. Now I need to merge these two together. I can do it on the command line as well, but through the UI, when it happens, it is called creating a pull request. You can see multiple pull requests. I'll show you one of mine. So this MindsDB project was there, and I added something to it from my own branch. This is the name of my branch. Okay, what are the changes that I did? I made all of these changes, right? All of this code I wrote. And I communicated to the developer that, okay, I have done this. These are the new features. I wasn't able to get some things right. Then they had some comments and they approved the changes they asked me to. Okay, done it. Then they said that they have merged this commit into their particular graph, right? Their particular repository. Let's do that. What I'll do is open a pull request. That means I have some code changes. You have some code. I want to reflect these changes into your own code. So fix issue number 1. This fixes issue number 1. Fix the typo. I'm just doing it for my personal project, personal repository, but I'll still write this. Do not much because this is just a demo. If I do this, what it is doing is it will send me an email. I am the developer. It will send me an email that someone wants to make some code changes to your code. Right now in main branch test.2.txt has nothing in it with health 0. But now when I merge this code, merge this pull request, what will happen is it is the same merge that we did on command line as well. So now it has changed the issue to merge, and this issue has now been fixed, right? But it is still showing as it has not been fixed. So GitHub allows us to do this, that if I write it that this closes issue number 1 and I comment it, it will actually close this issue. Closing an issue means I have just seen it and now it is done. Right. So it has not automatically closed it because it is only done when it is done for the first time. So I'll now manually close this issue. This is what an open source developer is doing when you are making changes to the code. This is all given to you. All these features are given to you using GitHub. So I'll show you some examples of other pull requests. So I wanted to do some changes. Okay, a lot of changes were done here. It's fine. But there was a conversation that followed, that I migrated these. This is related to this particular issue. Someone said that, can some admin please verify this? This particular developer was there. They had some comments that, okay, you are not doing it this way. You should do it this way. It's all fine. After that, they might say something that it looks good to them. LGTM means it looks good to them. After they have verified that there are no bugs in my code, it works. So my code will now be in the main project's code. And that's it. That's how you contribute to open source. But for that, you can start with some small things, just like documentation and other things, or just doing very simple changes. For example, this particular change, if you can see, one thing was this was added and just this particular line was removed. Change CSS line was removed. This was added. Nothing else was done. But how to do these changes? For that, you do need to like learn the skills on the way. But this particular session was how to use GitHub to your benefit. Now, this particular pull request that I had done a lot of work on didn't get merged, but I got credit for it because, and I can add it to the repository to my resume. Why? I didn't know anything about this Perl language, but I worked on it. Okay. What happened here was we were expected to create something. Let me not get into the details, but we are expected to create something for this particular language, and this project called Open Runtimes would run it. But for that, if you go to Geek for Geeks or any Code Chef or any lead code platform, you can select all of these different languages, right? But how do they run it? There are runtimes for each of the different languages that are there, and something like that open runtimes you can implement, you can integrate, and it will run the code for you and give you the output, and then you can show it for the user on the front end. So all of that was done. Some comments were addressed. They have approved my work. All of that happened, but it was not merged because their main project was like that went to some other direction. But in the process of this, I got to talk with some people. This guy right here and this Christy Jacob right here. You talk with these people. These people do not judge you on the basis of any other prior work that you have done. They judge you only on the basis of the work that is being shown to them, that is just this work. On the basis of that, they will just judge or review your code. If it is approved, it is merged, and you get the credit for it. So this is all about open source development, and like if it makes any more sense to you, sometimes they do send you some marketing material, like stickers and goodies and swags like that. But that is just a marketing stunt, because one of the ways that you can actually contribute was what? One of the ways that you can actually contribute was by doing the outreach for them. So that is why goodies are given. So yeah, that was my particular session on introduction to open source and using Git and GitHub. If it was useful to you, just let me know after the session. And if you have any questions, you can let me know. You can unmute and say, or just put it down on the comments. Is everyone good with it?
Yep.
Okay then, see you next time. Bye.
I just wanted
Okay.
to ask you
Okay.
how to find community, like for coding and all, like for open source basically.
Okay. You have come to the right person. Okay. Do you have Discord?
Yeah.
Okay. So if you have Discord, you can actually join some of the communities that are there. You can first of all join the MLH community and the Hacktoberfest community. That is one of the events where you can get started with open source, right? You can join the Hacktoberfest community, and here you will find some people who are working on their projects and the communities that they are from. So by this way you can actually get exposed to other communities that are out there. For example, there is this AppWrite community out there. There is this Angel Hack community out there, right? There are other communities out there as well. For example, iWell and Eddie Hub. So these communities, if you want, you can mail me or get in contact with me after the session. But by joining these forums, these servers, you will get access to all of these, get knowledge about all of these communities, and then you can join them based on your interest. There are lots of communities, Postman student communities there, lots of communities. Does that answer your question?
Yeah. Thank you.
Okay.
Can I connect you like on Twitter, X?
Yes.
Okay. Thank you.
Okay, then see you all next time. I'll close the stream now. Thank you. Bye-bye.